Today we start the annual progress meeting for the Fit4Micro here at BTG in Enschede, the Netherlands.
So it all started with the ideas of how can we actually supply energy for a house, for building, using renewable energy. And so we thought it could be nice actually to use some kind of biomass in a liquid way. So this is where comes actually our partner BTG to create this biofuel. We connect this to a micro gas turbine system in order to produce heat and electricity. And the heat and the electricity can be used afterwards to produce even more electricity, more heat actually using heat pumps, but also cool actually by using the heat to produce cooling using absorption chillers.
At BTG we are developing processes to convert solid biomass residues into biofuels, biochemicals and biomaterials. Within the Fit4Micro project, our task is to produce the biofuel for the CHP unit. The main target of BTG in the Fit4Micro project is to reduce the cost of HPO production. We do this by reducing the hydrogen content and by using low-cost biomass residues in processing.
We have been working on the development of a new atomizer, and we have also looked at the combustion properties of the Metis combustor. We have tested it with different HPO grades and we found very good results. So it was low emission of NOx and CO. And now we are looking also how to improve the combustor with a new atomizer and also with improved design.
So in work package 3, it's really testing the biofuel for a flameless combustion chamber to optimize the combustion chamber and to optimize the injection system to achieve the lowest emissions in the market. So to have less than 10 ppm of NOx and CO. And then we are also in parallel testing and developing the two-stage cycle at Metis to increase the electrical efficiency of the system. And together these two combinations where a combustion chamber that's optimized for the emissions and then a microturbine that's optimized for the efficiency, they will come together and we will test this.
And within the Fit4Micro project, we work on humidification of the microturbine. Any gas turbine, like any cogeneration application, cannot change its heat production without changing the electricity production. By doing cycle humidification, you can do this independently of each other. So by taking thermal power, you can then boost the electrical power and go to higher efficiency.
The work package 5, which is on the integration of the different technologies into a hybrid heating and or cooling system. We have done measurements already on a heat pump that will be integrated into the system. We've done measurements on an adsorption chiller, which makes cold from heat.
The assessment of such a technology system is really, really interesting because it's not just about the technology, the integrated system. It is also about where does the fuel come from. We are here at BTG producing pyrolysis oil, but the modeling of that oil depends really on where the feedstocks to the process come from.
Cogen Europe's role within the Fit4Micro project is twofold, really. To look at the political and policy implications for the technologies that are being assessed and designed for this project. Things like the European Green Deal, the Fit for 55, policies ranging from the Energy Efficiency Directive, the Renewable Energy Directive, but even more technical policy files like energy labeling and eco-design. All that will have an impact on the future of this technology. So all very exciting, and we're looking forward to finalizing the results and sharing that with the general public.